I'm going to begin by talking about CSMA-CA. All wireless Ethernet standards employ an algorithm called carrier sense multiple access with collision avoidance. That's CSMA-CA. A CSMA-CA network involves a method of transmission that avoids packet collisions. Once a node wants to send a packet, it listens to the carrier wave. If no other node is transmitting, it will then transmit. If another node is transmitting, it will wait a random amount of time and then listen to the carrier wave again to see if it's free to send. This differs from a CSMA-CD, which stands for collision detection, type of network, which is all about how to transmit after a collision has occurred. Now let's talk about frequency modulation. Frequency modulation is the process used to encode data into a carrier wave. 802.11 uses two main frequency modulation methods. The first one is orthogonal frequency division multiplexing, or OFDM. OFDM is a frequency division multiplexing scheme that uses multiple subcarrier channels to carry data. It is used to mitigate against attenuation, which is loss of signal strength over distance, and multipath issues that exist in networking. The other frequency modulation method is direct sequence spread spectrum, or DSSS. DSSS is a modulation technique that uses spread spectrum technology to affect data transfer. It is used to mitigate the problem of multiple users on a channel and for effective timing between the transmitter and the receiver. Now let's move on to the wireless standards. Wireless networking standards are established by the 802.11 Committee of the Institute of Electrical and Electronics Engineers, or the IEEE. Quite often the term Wi-Fi is used to describe an 802.11 network, which is technically incorrect. Wi-Fi is actually a reference to the Wi-Fi Alliance, which is responsible for certifying that wireless networking equipment actually meets the 802.11 standards. Wi-Fi has become synonymous with the wireless local area network in the English language, so don't be surprised if you find yourself using the term Wi-Fi when you really mean 802.11. Now let's talk about the standards, and first up is 802.11a. It has a maximum speed of 54 megabits per second, and it operates on the 5 gigahertz frequency band. It uses OFDM as its form of modulation and has a maximum distance of 150 feet. 802.11a is compatible with 802.11ac. Then there's 802.11b. It has a maximum speed of 11 megabits per second and it operates on the 2.4 gigahertz frequency band. 11b uses DSSS as its technique for modulation. It has a maximum distance of 300 feet and it is compatible with 802.11g and 802.11n. Now let's move on to 802.11g. It has a maximum speed of 54 megabits per second, and it also operates on the 2.4 gigahertz frequency band. 11G can use OFDM and DSSS for its modulation techniques. It has a maximum distance of 300 feet. 802.11g is compatible with 802.11b and 802.11n. Now talking about 802.11n, it has a maximum speed of up to 600 megabits per second, and it can operate on both the 2.4 and the 5 gigahertz frequency band. It does use OFDM as its form of modulation. It offers a maximum distance of 300 feet. 802.11n is compatible with 11b, 11g, and 11ac. With the introduction of 802.11n, we now find MIMO, multiple input, multiple output. It's a technology that allows for the increase in speed for the wireless network. With 11N, there can be up to 4 antennas which allow for up to 4 separate spatial streams. And finally, we have 802.11ac. Now, 802.11ac offers speed anywhere from up to 433 megabits per second up to multiples of gigabits per second, and it operates on the 5 gigahertz frequency band. It uses OFDM as its method of modulation, but its implementation is an advanced form of OFDM. .11ac offers a theoretical maximum distance of 300 feet. .11ac can be compatible with .11a, G, or N. When 802.11ac was introduced, they improved the MIMO technology, which now allows for up to 8 antennas, which means that there can be up to 8 separate spatial streams of data.